today we're going to talk about linear function patterns. A linear function, as you might already understand from the name, is a line whenever we have a graph that relates to it. Now, a function has to be a non-vertical line, as we have heard and shown through the vertical line test, and it can be written in the form of y equals mx plus b, which we have seen before through slope-intercept form. So basically, this lesson is something we've already covered in the past. We are going to write linear functions that relates y to x. Basically, guys, we're putting all of these into slope-intercept form. So I'll do the first example with you. So this one we have a discrete function, since we learned about that last time, because we have points of our function, but we don't have a continuous line that is going through all of the points. We are still doing slope-intercept form. We need to find out what our y-intercept is, which is b, which is at -1, and we have to find out what our slope is, okay, which is rise over run. So for our slope, I'm going to choose 2 points. I'm going to choose our y-intercept and our complete right point. Our rise over run, we go down 1, so it's our rise is -1 over 2. So if that's our slope, then that means that we can just plug in y equals m, which is -1/2, x plus b, or -1, because b is -1. And that's our function that relates y to x. It's slope-intercept form, guys. So go ahead and do the next one on your own. Pause the video, then check back to see if your answer is correct. All right, you should have gotten y equals 3/2 x minus 3. We went to -3 as our slope, as our y-intercept, which is right here, and then our slope was a positive up 3 over 2, and that's what you got. Now we're going to do the same thing, but we are given a table to begin with. So what I've done is I've provided a graph for you guys. All you need to do are plot the points and then create a function that relates y to x. Do the same thing as we did before. Go ahead and try to do this on your own, then check back to see if your answers are correct. All right, so your answers for these two functions are as follows. We have, on the second one, this is a Hoy situation. It is a horizontal line with 0 slope, and y is equal to a number. And as you can see, y does always equal -2 or equal +2. So that is our equation for the function. All right, now we're going to put this into a real world problem, and we're going to talk about the hours of kayaking versus the calories burned. Now let's look at what it's telling us to do. First, it's saying to graph the data in the table. All right, so we have hours kayaking as our first, as our x value, hours kayaking, and then we have to label our y values, which is the calories burned. Okay, it's always good to label your x's. All right, so I'm going to go ahead and label 2, 4, 6, 8, 10. And then I'm going to go up, let's see, I'm going to go up by 600. I'm just going to skip a line each way. So we're really going up 300, just to make this a little easier to see. And then we're going to graph our points. So let's go ahead and plot our points. At 2 hours, we have 600 calories. At 4 hours, we have 1200. And at 6, we go up to 18. And then at 8, we go to 24. All right. Now, when they're asking us, is the domain discrete or continuous? We're looking at A. We are going to say it is continuous because our domain of x are hours. We can have portions of an hour. So I'm going to connect my dots now. If it was discrete, we wouldn't have connected our dots. Now it says to write a linear function that relates y to x. So let's look at this. Well, our graph is kind of easy to see. We're just going up by 300 for every hour. So 300x. You go up 300 over 1. Or you could see that you go up 600 over 2. Well, 600 divided by 2 is 300. So that's your linear function. Then they're asking, how many calories do you burn in 4.5 hours? Okay, so what I'm going to do is I'm going to plug in 4.5 in for x. So when I do that, we're going to see that we have 300 times 4.5, and our answer is 1350. 1,350 calories. Please make sure that you label your answer. We have a very similar situation for this next one. Please do the exact same thing we did previously. You're going to graph the table. You're going to decide if it's a discrete or continuous domain. Write a linear function that relates y to x, that's slope-intercept form, and then find the final answer where you plug in a number. Check back to see if you're correct. All right, so this is the answer that you should have had. We have a positive line going up. Just ignore how it's not very straight. It is a continuous domain. We are again talking about the amount of calories burned, but also those hours of rock climbing this time instead of kayaking. You can have portions of an hour, minutes, seconds, partial seconds. So it is a continuous domain. And then we have a linear function of y equals 650x. That means you burn 650 calories for every 1 hour of rock climbing. And then in 5.5 hours of rock climbing, you actually burned 3,575 calories. Go ahead and check your answers and make sure you correct something if it's wrong.